reaches saturation as a result of the drive that it's attached to. So that would make these motors efficient, pretty much efficient at any speed.
Well, no. If it reaches saturation, then it's just going to heat up. You need to raise the PWM frequency high enough that it can't ever reach saturation. But if you raise it too high, then it takes so much current to, there's a sweet spot. If your frequency is too low, then the iron becomes saturated and heats up. If your frequency is too high, then you can't get enough current through, because you're Eli the Iceman, the current ramps up going into a coil.
Yeah.
And if your frequency is too high, it never gets above 10% or whatever. So
Okay,
you
now,
have to
so-
tune for them.
Okay.
And every
so-
motor is different.
Okay, but you tune for that motor, and your optimal, quote unquote,
Mm-hmm.
value will be fixed no matter what the speed.
Should be, I think.
Should be close.
Yeah.
Realizing,
A
we're
little
talking
bit.
generalities here anyway. Okay, now, what about the torque? If I increase the torque,
Oh, torque should be just monumental in a stepper motor of any sort, whether
Well,
it's a hub motor.
This
or
is really where we're trying to not use it as a stepper motor. We're trying to use it as an efficient DC motor.
Mhm.
And we
but
don't want it to be a
that's-
stepper motor.
But DC motors are torquey by default. A gas engine produces zero torque at 0 RPM, and the more
I'm not worried about creating torque. I'm worried about if you apply torque, somebody applies or restricts the rotation of the
Okay.
motor. What's that going to do? What's going to keep that motor from slipping? So you're saying that we're at optimal saturation at all times
Mhm.
because of, okay, now what about at zero speed?
at 0 speed, there's no reason to feed power into it unless you're trying to move it. And at that point, now
At
it's,
zero
it's
speed, I got to feed, and I'm trying to move it.
Okay, so if you know what your load weighs and how fast you want to go, you can apply the needed power to accelerate it at what you want.
Your needed power.
Yeah, horsepower is the ability to lift 550 pounds 1 foot in 1 second, or 745 watts. If you have a well-tuned motor and you put 750 watts into it, it's producing 1 horsepower, and it's going to move something or break something. So if you limit the input power, you limit the acceleration.
What is the... Okay, so I'm going to be sending, all of a sudden I'm going to go full torque on this motor. But okay, so the slip will be fixed by the fact that the frequency of the drive
Back to you.
is set. You're saying it's basically would have constant
Well, so
constant current.
so this is a synchronous motor, like
I
you
just
started
it.
out with.
I just like it.
If you drive it at 10 RPM, it will go 10 RPM, or it will slip.
At your fingertips.
You can make it more likely to slip by lowering the PWM, or lowering the apparent power,
at its best.
or you can make
for,
it.
let me get it in my mind this way. If I am trying to make it move, change the speed very slightly, why am I hitting it with full current?
Well, you
all the
don't. That's
time?
what the PWM is for.
So the PWM is for what?
to adjust the power applied to the motor,
Why would you adjust the power going to the motor?
Oh, missed it.
to allow it to slip.
Oh, I saw
To
that.
prevent
Yeah,
it from
that's cool.
slipping.
Well, you
That's
raise
cool.
it and it'll,
Yeah.
if you raise the power.
You don't want it ever to slip.
Okay, then raise the power.
To prevent, what I'm saying is, yeah, to prevent it from slipping, you would,
Yeah, really.
if you detect that you're behind the speed and you want to up the torque, make
Mhm.
sure you don't slip,
Mm-hmm.
okay, you would raise the power.
Yes.
Oh, updates.
And that
Don't
would be,
don't
how would
kid
you
me.
do that?
Gotta love updates.
By widening the on time of the PWM signal.
Okay, so you're saying you do widen the pulse width modulation.
Mhm.
Pulse width modulation has to do with what? Power
The-
that's
The
required?
apparent power applied to the coils.
Okay. Okay. So that's how you're doing it. You're not, okay. And you would do that to prevent slip, and you could adjust the power going to it
Yes,
to prevent slip.
yes.
That's where I'm
On
getting,
stepper motor drivers, the little cheap, crappy $2
they don't
drivers.
care.
No, they have a variable resistor on them that you set your drive current with.
Okay.
On the hub motor drivers that Leroy has, I'm certain that there's a way that you can adjust current on those.
On the driver, yeah.
But the current should
Yeah.
vary with the speed. Because at high speed,
So-
you don't need as much torque. You would think.
Probably true. Though, well, no, you need torque when your given speed is not the same as your driven speed. If you want to go 5 miles an hour and you're going 0, you need torque.
Well,
If you
no,
are hold on.
well,
If
you
you're
need-
going 5 miles an hour and you want to go 5 miles an hour,
you're going
there's-
to change the speed,
Hmm?
not the torque. You're going to change. You're going to need more torque. You're going to need more.
If-
Okay, so
Hmm.
you're saying changing the width of the PWM strength. You're going to increase the power. Is going to
Yes.
change the speed.
you also have to change the drive frequency. If you're driving at 5 miles an hour, your motor is either moving at 5 miles an hour or it's slipping. If it's slipping, you raise your PWM percentage until it stops slipping. But once it gets up to
So
speed,
you're saying you would increase the oscillator speed to say speed go up, or are you? So how can you tell that it's it's required by torque? How can you tell that the speed is shifting because of torque?
by looking to see if you're cogging. That you read one of the Hall effect.
You should
sensors.
always cog. You should
No,
always
no,
be.
no, no. Your Hall effect sensor tells you the speed the rotor is turning. And if you say
But
move
the
forward
speed-
a
the
step, move
speed
forward a
is-
step,
is-
move forward a step, and you hear back, I've moved forward a step, then you are slipping. If you raise the current, you will be less likely to slip.
I would be shocked if any of these guys ever slipped.
Oh yeah, I mean, I got on one of those hoverboards and it moved my 240-pound motor.
It's got enough torque to but yeah, the thing I'm seeing is if you want to increase the speed, at least I'm learning they are adjusting the current going to it by adjusting the duty cycle, and I'm
Mhm.
saying what's that? And you're saying it's a function of speed or slip
No,
or
the duty cycle is what determines the power of the motor. The drive frequency is what determines the rotation speed.
the power of the duty cycle determines how much power you're sending to the motor. or how much power you're putting on the coils. The power though, here it is. The power in a drive that's always, if you have a motor that has a current on the coils that is not saturated, and you determine what that current is, then you set that at that current, and then you simply adjust the speed to change the speed. You don't ever want that motor to slip. You don't ever want that motor to slip, ever, ever, ever.
True.
See, slipping on AC motors sucks really big.
Could you draw a picture?
Me? No,
I'm
not
just,
now.
I mean, okay, well, I got a
But
really,
I got some ideas.
I got a
Thanks.
really stupid question though, real stupid. Okay, when you say increase the current,
Mm-hmm.
now it's something I'm missing here because the motor is not a source. It's basically pulling. It's getting all it can. So when you increase the current, how are you actually providing increased current without the motor asking for increased current? Are you saying
by driving it with PWM,
okay?
you change the apparent current through the coils
Right.
by changing the voltage across them.
Okay, right. Then that makes
So you raise your voltage, you get more current.
Okay, that makes sense. That makes sense. Okay, I got you. Because when you
Raising the voltage? Raising
it effectively does.
Right.
Yeah,
The PWM
it's
working
changing.
with the reluctance of the coils is what determines the current through them.
Yeah,
And it does that by
increasing the current by changing the pulse width,
yeah.
and appearance
It
to have a higher
appears
voltage.
to be voltage.
Yeah.
Yeah.
And
So-
that's one of the issues we got here. I'm having to convert to like it's an AC motor or a DC motor, and it's
Well,
not
and it
converting
is.
directly.
I mean, an AC synchronous motor at speed draws very little power because everything is all synced up. When on your table saw, that thing probably draws 5 watts once it gets up to speed. Stick a board
You
in
can
there.
load it, yeah.
Stick a board in there, and it slows down. It produces 100% of its torque at stall, and as its speed increases, the torque is reduced. At synchronous speed, torque is 0. As you fall off of your torque, because of the reluctance of the coils, your load increases and the current draw goes up, so the power goes up as it slows down, which is the exact opposite of a gas engine.
So we have to know, we're not measuring the current and saying we need to increase
No,
the
that's all
current.
done by magic. That's
Okay.
done by where
We've
the
got to
coils
figure.
are.
We got to figure out the torque.
We're
Sorry.
back to my
magic.
magic. I already I explained it all when I walked in here. I said it was magic.
That's
Now
it,
we're just back to magic.
So it's my question has to evolve of how are we measuring the torque?
Marcus, everything electronics is magic.
Yep. Don't let the smoke out.
Smoke in the ears.
Okay,
It's all magic.
so we're getting there. I'm trying to get this ironed out. And someday, maybe years from now,
Are you?
we'll know.
Is that a continuation of your Vicente
Yeah,
Yeah,
renovation?
yeah.
that's what I'm
Strongest
saying.
hard drive magnets I've ever come
So that is
across.
not here.
Thought those were.
That was good.
He probably didn't show up because I sent that.
Yeah, that's right. Like
I wouldn't have showed up. That guy's crazy. Other
You do not want to let this thing get to your fingertips.
So,
We
Is it that powerful,
we put
really?
those rare earth magnets on ready mix trucks, and we're using them to count the revolutions going around.
Mm-hmm.
Same, they're powerful. You let them snap, they'll shatter.
yeah.
Yeah. Don't let these touch each other. No. Pick that one up.
Really?
Yeah, don't
But you
let
can't get them
touch.
apart?
Yeah, you want to get it
What
across
about-
the thick part of your hand if you're going to do
How
that.
about the table?
Yeah, oh yeah, it'll go through the table easy. Well, turn that one over.
Jesus.
If you let them smack into each other,
Whoa.
You're stuck to something metal on the bottom
Yeah, I
of the
know.
table.
That's like, I know. That was like, whoa.
Yeah, watch your fingers.
Marcus messed it up.
Oh, like a,
Look at how thick that table is, and it's still going to do it.
On
No,
a
the
ready
weird-
mix truck?
Yeah. We were doing process control systems, getting the viscosity of the concrete right as we got to the job.
So you got Hall effects around it and whatever, and counting pulses off of it.
Yep, 12 pulses per turn.
I can't get it off now.
You've done lost your magnet.
That's
It's gone.
right.
It may be stuck to a screw or something inside.
I'm gonna get that one over there. Let's see.
Keep them apart. Don't get them all
Yeah,
mixed.
you don't want to get this one anywhere near your credit cards.
Wow.
Yesterday, this is what I was
Look
working
at
on
brake
yesterday.
pads.
Yeah.
It looks like brake pads, doesn't it? This is what I was working on yesterday. So this is at the
Oh,
Middletown Library in their big community room. So there's my Aruka markers. There's my robot. It'll go to that one. And then it'll find the one that's down here close to where I'm sitting. That's part one. Hey, everybody wait.
All right. Cool.
And
Yeah, that's cool.
then part two.
So your Arukas, they're about 5 inches square.
4.72 inches.
It's finding the same one twice in a row is cheating.
I'm sorry.
okay.
Okay, let's try this one then. Wait a second. It didn't start. Why didn't it start? All right, let's try this one then. Actually, it found it. The second one. I hit the button. I hit the wrong button. So I told it to come back.
You told it to come back. Okay.
Oops. It's what happens when you have a cell phone in one hand and you're trying to do something else,
Yeah, like drive.
like drive. So I sent it
Cool.
back up there. I did it right the third time.
Nice.
um,
Come on.
so the program. So that's version 2 of that robot. The program. Remember last week, it showed the web interface. I converted the web interface over, and there's still some problems with that program.
It's
And Mark missed it. Mark got to see it.
Looks like you modified the camera head. Or how it
No,
is that saying?
no, it's pretty much the same. Yeah.
Hey,
So that's what I've been working on this past week.
I've been
You're up.
well. Actually, I'm going to show it a little bit today. I've been working on the, and I'll bring everybody up to speed on. Of course, everything's IoT for me. So anyway, I've been working on. I don't have a lot of Christmas lights, but I have like candles in the window. Believe it or not, 2 Christmas trees, and I use timers all this time, AC timers to to get them on. So it's like okay. And last year I started to improve that with the Sonos, but for some reason I probably was me, but I didn't spend a lot of time on it. I couldn't get them to work right, and so this year, since I've gotten more experience, had them running in the house forever now, so that's what I've been working on, trying to get those so I can synchronize the candles come on, control all the trees, everything in the house and stuff. So anyway, I'll show that after. You're next.
Oh, I'm next.
I got questions.
You got what? Can you? Uh oh.
By Sunday, he's got stuff too.
Luckily, I won't take long. Wow. See, you thought he wasn't gonna come.
I wouldn't have come if you were asking me questions like that. So that guy's nuts.
Oh, what's that cord?
You have any leftovers?
Okay.
So, Mark, what have you been working on?
Me, Mark?
I'm Mark Gus. You are Mark.
You're Mark Gus, okay. Well, I didn't know if you were finished with that word or if it was. All right, so working, what have I been working? I haven't been working. I've been playing.
That's good. That's it. That's part of it, isn't it?
Well, it makes it go a little easier if it's fun. I'm working on making 2 more prototype robots that are the same as the second one, the previous one. So it's just
The same or similar?
try to make them the same so that they are consistent. But yeah, I made a few improvements, which the word improvements in air quotes, right?
Yeah.
Improvements.
Prove it.
So anyway, that's pretty much it. It's been time consuming and
Oh,
a
yeah.
little bit boring, but it's kind of
I saw you go
Development.
a couple of hours
work.
ago.
Yeah.
Enjoyable work.
Anytime to
Sometimes it's frustrating,
it's
other
not
times,
making
but
any
that's the
sense.
way everything is, I
No,
guess.
it's too much
Watch
stuff.
Watch this. So, Jim, what have you been doing besides harassing Vicente?
Uh-huh.
My issue this week was some of my cameras started acting up. We were talking about it before the meeting, and I was a Snickers boy, want you to know. So anyhow, I had a camera blow up, and some of my other cameras were dropping connections, and one of my Wi-Fi hockey pucks stopped working and started an error, flashing an error. And so I rebooted everything, and things are still not going that well. And I turned off or disconnected a camera that I just transferred over to a fixed IP address. There was no IP conflict. I checked it before I moved it over. And everything was going bad. And so I took the camera off, and everything's much better. But my hockey puck was still erroring out, and I brought it downstairs and told the app to re-find it, and it found it, and everything's great. Everything's made for love. So I'm wondering if DHCP might be an issue. Have you seen any? Do your Sonos do DHCP? Are they DHCP?
No, they don't. They just,
They're fixed?
yeah.
Oh, okay.
But I will tell you, my broker,
Oh, you're
Pardon?
trouble now.
yeah,
Do
I mean, I do have devices that do pick up their IP address from the DHCP server. Actually, I got them from the actual modem. So, that's the problem with technology. It's like it goes out, and then you have to go troubleshoot, and it takes so much time to troubleshoot that daggone stuff. Then you ask the question, do I really need this?
In some ways, I use DHCP, but I generally make static reservations by the
Mhm.
back of the device, so you know what it's going to be.
Mhm.
And then there's a DNS server that allows me to use names instead of addresses.
What is your application? Is that for cameras also, or is that?
No, it's mostly for little Linux modules, security stuff, and lots of little stuff.
You're next.
You're next.
I set up Nginx last weekend to do reverse proxy for a bunch of those little devices, which was kind of cool, because I was running out of public IP addresses, and now it'll route to the right web server based on the name.
Cool.
That was fun. Well, not quite fun.
Now,
It
when you
was
say devices, what kind of devices?
single board computers.
Okay, okay. Does that work?
It's work.
Oh, that's work?
Yeah.
single board computers, plural, you've got multiple? Dozens, okay.
So what are they doing? What is
They're
their?
VMs too.
Oh,
The
okay.
SXI and do automated testing and Jenkins and
Automated testing, that's what the use they're being put to, or?
yeah.
Okay.
Some of the VMs, they're build nodes, so each of them will have a different compiler tool set on them. They'll check out the code from the Git repository, build the applications, deploy it, run the testing. It's continuous integration, not delivery. They do continuous delivery.
So they're testing computer code, or are they testing a physical device?
Both.
Both,
It's
okay.
Yes.
actually end-to-end testing. I simulate the inputs, and then at the other end, I generate the PDF reports, and we're parsing the reports and making sure the events that were triggered by the sensors show up in the reports. So you got full end-to-end without actually testing anything in the middle directly.
Okay, what is I think we're both trying to get to this point of understanding what's the end product of what you're actually creating. It's like, so you get this impression that it's some sensors out here that's communicating with this.
Or is it confidential?
No.
Yeah,
so
that's what-
they
You missed-
sell this.
that's
into,
what I was thinking.
You missed.
Yeah.
You missed it 2 weeks ago. He brought the whole thing in
Ah,
and explained
okay.
everything.
Okay.
See what happens when you miss a meeting?
I know, right?
It's a
You can go
lot.
back and review it,
Yeah.
right?
Yeah, well, it saw it.
You missed it too.
Actually, based
Yeah, I don't
on
believe it's true.
your concerns, I marked it as private, but I'll share
Yeah,
share
it's
it
not-
with anybody.
It's not private. I didn't say
So
Okay.
They sell it to courthouses and hospitals.
Okay,
It's just duress panic systems.
okay,
If you have on-site security, this gets their attention.
okay.
You hit a button, break a window, motion sensor.
Oh, okay.
Very good.
just say I did this 2 weeks ago and you guys missed it. See
Go
what
watch the
happens?
video.
I'm going to be bored in.
Then
These are fun.
he'll say,
Cool. New thingy-mabobbies.
So these are
Oh,
just new
stairs.
sensor inputs, right? This is Western Reserve. It's actually an Ohio company. Standard
Oh, you
modules,
get
you
the
may
little
recognize these as
Yeah.
Opto 22.
Opto 22.
Exactly. So this makes them wireless and brings them into the system. There's my. Now, unfortunately, I only can do the inputs here because this is a transmitter. It's not a transceiver. So I can't use the output.
I just happen to have them in my pocket.
But of course I do.
Are those up to 22 grand?
You have
Or are they,
something-
They're
Yeah, that's right. I'm like,
Western
we all pull out.
Reserve, but they're just like they're incompatible.
okay, gotcha.
So those are the inputs and outputs.
Up to 22.
Let's see. I've got
These
some
are
of this
Western
stuff
Reserve.
here.
Those are smaller than the old Optos anyway.
So Western
Yeah, these
Reserve
was-
is Cleveland.
Opto's got a couple of different ranges depending on the current you need.
Cleveland? I don't remember. They are Ohio.
Yeah,
Though.
I use these forever.
Yeah, this one's fun. What's neat about this is
It makes it all wireless.
5 to 24 volts can come in here.
Yeah.
And this little module right here, this sucker will give me 2 amps at 3.3 volts. 200 milliamps at 3.3 volts over 4 to 36 volts input. That's a huge input range.
Yeah.
And the only other thing I had to add to it were these 2 caps. So, it's sweet.
Cool. Now,
There.
now we're up to speed.
Now, are you happy?
Yes.
No, I'm never happy.
Never
I
happy.
said happy.
Talking about technology.
Now I just
Yes,
have more
right.
questions.
Now,
Yeah.
Jeez. Don't encourage you.
Okay, 12 buffers, 8 relays.
This is available up to 24.
So
There's
each
a-
of these is a dual?
Yeah, I'll do
Okay.
all 24. There's probably, is there 12 on there? Yeah, there's
Yeah.
12 times 2.
Nice.
Sounds like fun.
cool.
That's good stuff.
So we know Steve brought super duper magnets.
Yeah, magnets if anybody else wants to play with them.
Danger, Will.
Yeah, be
I'm scared
cautious.
of them now. I'm afraid.
Now they're
Yeah,
together.
I got them.
think
I
you
got them
can't
stuck
get
to
them
Can't get them apart.
Yeah, I know.
Find the plastic screwdriver.
I
Yeah.
got it stuck
Find
to the
that
bottom
off.
of the table. Couldn't get it off.
So, you've been playing with Nginx. I've been getting rid of Nginx
Oh no.
because I have a bunch of Nest server installs. And a week ago, they found a 0-day, and the problem is in Nginx, but it only seems to affect Nest servers. So, yeah, I lost a lot of sleep on that one.
Sorry to hear
And there is a noticeable difference in speed between Nginx and Apache.
that. Apache being slower?
Yes, like
On magnets, yeah.
half the speed. I mean, it's impressive. Yeah, I'm hoping they fix it and I can move back.
You hope you want to go back to it.
Yeah.
So I put 4 devices behind it, and it's running on a Nginx is running on a virtual machine with 2 gigs of RAM, and it's
Mhm.
you don't even
Yeah,
notice.
yeah.
It's just like
What?
It's your turn.
yeah, there's no child labor.
What you got going
Oh,
on?
yeah.
The
I am
boards-
working in
Slave driver.
in a deck stairs, woodworking, and trying to solve the mystery of the encoders for the hoverboard wheels. Finally, I think I have something.
Yes.
Good news and bad news.
The good news, I found the problem. The bad news, I
No, I
can't fix
solved the
it.
problem, but it's not a generic solution because Hall effect sensors are installed in electromagnets in the motor, and the controller knows when it apply power to the magnets or not. So he can
Oh,
he knows when the data from the Hall effect sensors
is
are
relevant.
related to the permanent magnet instead of the coil that he is actually driving.
Okay,
So I am trying to sense in parallel to the controller
yeah,
what's the value of the Hall effect sensors
yeah,
and filter them, and in some way I figure out how to solve the problem, but you change the controller may be a different solution that you will need.
well, are you I don't want to.
No, the
I've
Hall
got a
effect sensors
question.
produce 0 to 5 volts digital output,
Yeah,
just on off.
yeah,
And it tells you if there is a south or north pole magnet in front of him. Okay, but
Yeah.
he is inserted in a electromagnet thing.
right, that's the.
So the controller use 3 of them to sense
Right,
where the permanent magnets are related to the stator, the internal
yeah,
array of electromagnets, to decide how to apply power to move in one direction or in another direction.
right,
When the controller apply power to the coil,
right,
for a fraction, there are pulses that are not related to the permanent magnets, are related to the energy that
the
the
dynamic.
controller is
Yeah.
applying. And you need to filter those pulses and figure out what magnet is close to the sensor. I did that using low pass filter
Yep,
and a buffer. Tomorrow I will have a Smith trigger buffer that is better to repel the noise. But I already have it working, but using 4 interruptions to manage all the troubles.
okay,
But it's working pretty well with this controller. I don't know if you change the driver, the energy and the high frequency modulation can produce another stuff. And maybe you lose your count of the wheel.
so sounds like that's what you're going to demonstrate today?
Yeah, I will
Okay.
demonstrate how it's working
Okay. Thank you.
when I have chance.
When I stop asking questions.
No, maybe later.
I do have a question, but I'll wait.
I think that brings us back to you, Marcus.
Okay, I'm gonna make this quick. I'm done.
That was quick.
That was quick. Okay, anyway, so everybody pretty much seen my last rendition of reviewing my IoT stuff through the house and all this stuff. I applied it, put it into effect.
Your project is the lamp? Or
Huh?
The lamp.
The lamp.
That's the new thing.
This is your project.
Yeah, that was the lamp, making the lamp.
Nice.
I just made the lamp. Forget all the electronic stuff, just the lamp.
Just
No.
you reinvented the incandescent light bulb.
I reinvented plagiarizing Google images for the lamp. But anyway, so this is the old, and really what I want to show you is two things. One of the things, my original goal is to basically interface my Christmas lights and make them controllable by this control panel. And this control panel is basically a Raspberry Pi with a display, basically. And actually, that display is actually sitting under my counter in my kitchen. So that's actually what it looks like, and all it was doing is controlling that lamp. So as you guys all know, is that this what.
One whole display just to control the lamp.
No, actually, no. It's more than that. It's actually,
Okay.
it's actually, if you go down the side, which is,
Yeah, I see.
Yeah,
I'm
it's
just giving you a hard time.
But this is only applicable for this discussion. The other stuff I've shown before, it's actually our calendar on there, and actually you can look on the map and see what the traffic jams are real quick, things like that, or the other things. But for now, we'll just deal with this one main panel. So anyway, so I created this. Oh, I can't believe it. I went back and looked at it. It was 2 years ago. I'm like, you gotta be kidding me. So it's been 2 years ago since actually I went in and modified this. And so, but basically, quickly how it works, everybody's, it's got this MQTT. The thing that every time I open this up and start playing with the MQTT broker, I'm just amazed at how easy it is to add stuff. I mean, just like, and you'll see, it is actually a phenomenal technology, because it just makes it so you just add stuff. You go into a program, you add a topic. It's basically this long, basically string with forward slashes in it, and it sort of tells almost like an address, basically. But it's just neat. It makes it so easy. So I can actually duplicate this panel in another room in the house and control the same stuff. It was just that easy. So, but anyway, so this is actually the old thing, and I want to show you. This is what it looks like now. Ta-da! So, on my way to Grandma's house, I first started out with just creating this part over here, which is actually the Christmas light stuff, which I'll explain. But on the way to Grandma's house, I was like, wow, well, since I've opened this thing back up again, let's add some more functionality. And so the cool thing about what I actually added is now it's not only one-way communication, now it's actually two-way communication with this panel. And what that means is that if the family room lamps are on, this will actually turn red, which I'll actually show that. And if the garage light's on, this will be red. And the cool thing about it, actually I put this as a double click, so I can open the garage door here. So if the garage door's up, this will be red. If the second garage door's up, this will be red. And I'll explain this part over here. But I'll do this part first. So there it is. Actually, I did actually show that. So that actually shows when the fireplace is actually on and the garage lights on. So.
Is this a presentation or a real thing? This is the presentation.
This is just presentation. Yeah, I'm not.
He just
Well,
opened his garage door.
Yeah, that's right. That's good. Yeah, I just opened the garage door.
And everybody's standing around going,
Yeah, my wife said, okay.
Marcus isn't around here.
Did the dog just open the garage door? So anyway, but that, there's all presentation stuff. I'm not good at trying to get all this stuff hooked up here, pain in the rear end. So, but yeah, actually I did change the date. That was 2017 was when I created the original. Now it's 2019 anyway. So, but so what I wanted to do real quick is just, sometimes even since I use MQTT a lot, I sometimes still get confused about it. So I just want to go through this quick little thing of how it actually works, just because I actually do a little different. I've learned some things along the way that makes the whole development process, not only the development process, but also the using of the devices. And one of the things I've learned is that, for example, and I'll just go through it real quick. So basically what happens is, and this is actually for the garage one. So if I push the button here, what happens is that it's actually gonna, they call it publish. I'm actually gonna publish this string over to this broker. And it's just gonna sit there, it just sits there, the broker he's just sort of a cop. And then this device over here is actually subscribed to that same address, if you will, what was actually published here. So as soon as this published something, the broker says, okay, I got it, and it indicates to this device that, hey, you got it, come get it. So it gets the information, and then it has that's what they call a payload hooked up to it. So in this case, the only payload is, it's a little more than this, but I actually send a long string across which has the date, the time, and a device ID. But in essence, it's basically on and off. It's basically sending it on and off. So in the simple terms, it goes up, gets the payload, it deciphers the payload, and then it says, okay, turn the light on or turn the light off. Now, the other part of this thing, which I learned over, just from doing it, is that what I really want to do is I want to send back the information that says that here's the status that I'm in. So once this turns on or off, the program goes through and says, okay, now I'm going to check the status and see if the light bulb's on or off. So it checks the status, and then it publishes that back. Now this device over here is subscribed to that same address, so it goes up and reads the address and says, oh, you're on. So it goes in, turns this to red and says, I'm on. So again, that's just over time, it's like I was always doing it just one way, but I learned that, okay, what we really need to do is to be able to check the status. So at any point, I can actually go out and check the status without changing the state of the light. And another thing I do all the time too is that I always put in a heartbeat. So it's like 1 second pause that I can go look at the device and say, oh, it's still working. So I can quickly see if the device is actually on without going through some test process or anything like that. So again, it's just, that's when you start putting things out in the wild and it's like, okay, I'm going through this looking, is it on? I don't know. I gotta go in. I gotta go in. VNC over to the device and check and see if the broker's running, for example. And it's just it's a pain in the rear, and so it's easy to just have a little displayed out there. Okay, it looks like it's live. So anyway, that's that part of it.
You have another color or
So
icon when the device doesn't answer?
No,
for
I
some
don't.
reason,
No, I don't do it when it doesn't answer. The only live signal or visual signal is just that heartbeat with the LED coming on, but it doesn't change colors. It's just one color. It's just on those particular ones. It doesn't have like multiple colors. It's just one. Now, what I actually do is like is that if I turn it on and it goes, number one, it goes and tries to find a Wi-Fi connection. If it finds the Wi-Fi connection, the next thing it does is goes and checks for the broker. It has to connect to the broker. So if it doesn't find the Wi-Fi, that's it'll be 2 blinks. If it doesn't find the broker, it's 3. So I use those as determining by the LED to determine what the status also is. Not only, so if the heartbeat's not working, it may be actually in one of those, and it just keeps on. And also I have it so it'll actually recycle back through and try to establish, then do Wi-Fi once and say, okay, I give up, I'm not doing this shit no more. It goes back and checks again and keeps going forever until till it actually finds it, which is pretty nice because sometimes it loses its brain. And then at the end, I think I have it cycling several times, then it'll just reset itself. So again, it just resets the whole thing and starts all over, and then goes and checks.
But if you're only looking at the power panel display, if that's what I've got, and all the other stuff's in another room,
You want to know if something is offline.
then I've only got a red and a green feedback saying it's on or it's off. But what if we don't know because heartbeat failed?
Well, and the other thing I do have is that there's a little X down here, which I just put as X. Okay. This is actually it actually goes out and checks the connect. This device also checks the Wi-Fi connection and also the MQTT connection. Now, if something fails in the actual device, it's not going to know. It's not going to know. But like, for example, and I didn't code it in, but I could code it in and say, okay, if it publishes and it doesn't get anything back, so it could. you know,
You could gray out your button.
Exactly,
if,
yeah.
If the heartbeat fails 3 times. or
right,
something.
yeah. I mean, it's endless to what I mean. I think you know we all sort of play with software, and that's the gorgeous thing about software, right? I mean, it's just you know, it's like you could do anything you want. You know, I mean, I could have done this little extra stuff here, actually sensing to actually do this, but this just happens to be 2 years later. You know, when I open it back up and say, okay, well, I'm going to spend the time to go ahead and do this. You know, it's just, but it's endless. I mean, we all know it's endless what you can do. I mean, it's just there's really no limit. And that's the exciting part about this crazy stuff, really.
When you program the power panel display, can you do it on that unit, or do you do it at a
I actually,
laptop?
I have to do it on the computer and then upload to it,
Mhm.
and this particular one is actually, this is all actually from Visual Studio's Universal Windows programming language. Basically, it uses and I like that I mean, it's a pretty neat. I don't know if it's catching on the outside of Microsoft, but it's really a neat language because it separates the code base from the actual UI base, and it's like you're always programming sort of in a web type environment.
So is that power panel device, is that sold by Hypertech?
No, not at all.
Okay,
no,
okay.
No, I just that's actually
Okay.
my low key consulting stuff I do. So
Okay.
it's just
It's just a 7-inch touchscreen on top of a Raspberry Pi.
Gotcha.
Yeah, and I
Okay,
don't have a
okay.
picture. I don't-
You
Yep.
brought it. He's brought it in here
yeah.
Yeah.
before.
It's just-
I
many
missed
years
that
ago.
meeting.
Yeah, I didn't miss another one. Huh? No, but it's just a nice display. It's somebody came up with it. They create them through
Yeah,
3D printers and stuff, and it's just
It's a commercially
yeah,
available.
yeah, it is.
I think I have a couple of them.
Yeah, they're just nice. So again, and you can mount them separate. Like I said, this one actually is actually sitting underneath my like a cabinet and over the counter, and it sort of swivels back and forth, which it looks actually pretty nice. So anyway, that's that. So you guys know me. I'm sketching it all.
Did you have
Question?
Did you have a question?
Oh, you want to get a second panel, and so that you make sure your communications will allow you to have 2 points to control it from and 2 points to give you feedback. Because if it works with 2, it'll work with 5.
Yeah. No.
But
Exactly. No, and that was actually my point, is that because when I started, this actually sits on, I mean, I have one sitting on, I didn't develop on this one, I developed on another one that's actually sitting on my desk right next to me, but I still have to code it first and then run it. You have to download and run it inside the actual application. I
but
can't
both
run
of them can control the same light.
Yes.
Yeah, okay.
Yeah. Oh, yeah, for sure. And they'll indicate whether it's on or off. So because it actually, as soon as you update something, it gets that published back that says a status changed. And then
Have you ever used MQTT?
I've looked at it a little bit. I think AWS is pushing it as a service.
Yeah.
Mm-hmm.
Yeah.
Yeah.
It's when was it? It was late, early '80s, developed by IBM for the pipeline, low latency devices, so that it was designed for this kind of thing.
application.
And it didn't
Low
catch it. It
bandwidth.
took a while before it
Short
caught on.
messages.
Yeah, it took a long time before it actually caught on.
Well,
It just-
The makers kind of found out about it and latched right onto it as a good IoT
yeah,
solution, because
perfect.
I mean it just sort of works.
Yeah.
So I've got a question too. I'm sorry, did I?
No.
Okay. So I might be a dummy, so I'm going to ask the question anyway. The words publish and subscribe, are these used everywhere, and I should know them, or is that something that's...
For MQTT,
Yep.
MQTT is a message. It's a messaging service.
Okay.
I forget what it's. Telemetry is one of the T's.
Okay.
You subscribe to a topic. You can You create the topic, or you can just subscribe to one that already exists.
Okay.
But you subscribe to it, and then you publish to that topic. So somebody else anywhere in the world can subscribe, as long as your broker is available worldwide, they can subscribe to the same topic. And as soon as you publish something, everybody who is subscribed to that topic will see it in about, it's a few nanoseconds. It does not take long for it to show up.
Okay, so the arrows on this picture are both pointed towards.
Yeah, and that's
The middle Raspberry Pi there, that's his broker.
yeah, and
Right,
and that's a little deceiving. And I actually went back and forth on how to show the arrows.
Okay.
But in actuality, they are actually communicating that way they're actually communicating all to the broker. But you could say, from a data flow standpoint, I can turn this around and say, this is publishing, but this subscription is actually, the data is actually going to flow this way.
Yeah.
But in here I have to subscribe to this. So it's kind of,
Okay. Okay.
yeah, go ahead.
So
He's got the colors right. So the publish and subscribe on the
Right.
red are the same topic,
Right.
and the publish and subscribe on the black are the same
they're a
topic.
pair.
There's
Right.
two different topics.
Okay.
He's got, in
And-
this particular situation, there's
Right.
two different
Okay,
topics.
okay. And then when you subscribe, is that a one-time event going that way to the broker, and then it's a repeating thing going the other way?
Well, you subscribe. It's like saying that it's like posting your address on your house, right?
Okay.
And then the mailman, you just post it out there one time. The mailman keeps,
Yeah.
he's
That-
publishing
that-
your
right. That,
yeah,
that's
yeah.
Gotcha. I think I
Right.
think I understand.
Right. Yeah.
Okay.
But is it republished? Does the panel know if the broker got the turn on the light signal?
Yeah. The only reason you can set it up. There's 3 levels of verification that you can use within the broker. But I'm using. They have actually it's 4. I think it's 4.
Yeah, I think they've added
I think
a fourth one.
I think it's 4. But they have it so that I have it set down to the lowest level. In other words, I don't care. I'm only going to send it once and that's it. But you can set the broker up so it verifies the fact that that person received that or that device received that. So you can set it up like that. But
you can publish a message to the broker and have that that message just sit there in the broker and wait for somebody else to subscribe to it until that message comes back out. So that message could sit there for one day, or it could sit there for
Right.
100 years until somebody subscribes to that topic.
yeah, and that's sort of another nice thing about it, because it just sort of sticks it out there and says, "No, I'm done."
Yeah.
it's like I'm done. It's like
it's
the
really-
client server thing. It's like client server. We went away from
Well,
this.
it's more like UDP.
Well, of course, yeah.
Sends it one time, and I hope you got it. At the lowest,
At the lowest, you're right,
at the lowest level.
right.
There it is. Hope you got it.
Yeah.
I don't care if you got it or not, but I hope you did.
So what are you talking about? The published part of it?
It's
Both.
it's the whole communications. The whole
Oh, is it
communication.
broadcast messaging? It's not connections? It's not TCP connections? No, it's just-
No,
No,
not at all.
no, it is not easy.
So in your house, Marcus, how many, if I could, how many of the brokers do you have in your house?
I actually have one broker.
Oh, one.
It's only one broker, but I have 20-something devices, maybe more. Probably more than that.
But it supports that many, sounds like it supports even more.
I don't even know that. I don't know. I've read it somewhere, but it's a lot.
A lot.
I'll say it
It's-
that way. It's a lot.
It's a lot more than what you're
Yeah,
ever going to use in your house.
Yeah, and it's not, again, keep in mind, the messages are really short. They're really short. I mean, they're short messages, so it's not. I mean, they're cranking them out just that easy. So it's not these long messages and it's not a big overhead like TCP/IP.
No, there's
TCP.
almost no overhead to it.
Yeah.
You got to. It was designed back
When bandwidth mattered.
when bandwidth mattered. So it was designed back
Yeah. When they're looking
when everything sort of
Efficiency.
and the networks were slow to start with.
Right.
So
Okay.
they designed it to. There's a message. we're done. Hope you got it, kind of deal. And then somebody later said it would be nice to know if we actually got it, so they built level 2, which would wait and get an acknowledgement, and then like level 3 would have the message sit there until somebody actually wanted it. And I'm not real sure what level 4. I know there's a level 4.
What's that? The dead. What is the dead?
Oh, the last will and testament.
Yeah, last will and testament. So
yeah, that was added for IoT stuff.
Right. So, okie dokie.
Do you use that? Do you use?
I've played with it, but I don't use it really because I kept everything pretty simple because it makes it easy to troubleshoot. So I was like, okay, it's like so I played with it enough. I played with all the different levels just to understand it.
Yeah.
You know how it is. It's just you get to a point. It's like, okay, but I'm putting this in practice.
Yeah, I played around with that where it would have the message sit there forever, and that was not.
Yeah.
That was not at all what I wanted it to do.
So I have another question.
Again?
Mark is full of questions.
I'm just messing with you.
No, you're fine. So all these signals are basically discrete signals, on off. Do you send?
The only reason it's on off.
Yep.
It's just a message. So
Right,
it's
right.
How, you can interpret the message however you want.
Well, no, but I mean, I think I'm getting, but I mean, as far as I can see, not that my eyes are that great, but you've got on/off that you're commanding, and then you get a result back, which is the indicator bar above red and green.
Right.
Okay. Could you send the lamp an
To the
analog signal
50%.
like 50% or something?
Of course, if it has that functionality, right? I mean, it's just. I mean,
Well, let's say the lamp has a dimmer switch.
Yeah.
in-
Now, yeah. I mean, the thing you have to understand here. This is sort of the lamp controller, right? So right now I'm only using one little output out this thing with a relay on it that says, okay, turn the dumb lamp on. Duh.
Right.
You know, so if there was functionality that said a dimmer switch and it was a resistor or something like that, or a resistant base, or whatever, I mean, or pulse width modulation, I mean, yeah, you can
You can do it. You
yeah,
can do all that.
yeah.
Okay.
I mean, it's
Yeah.
it's just the thing that's gorgeous about all this, and go back to the software part of it, right? Because when this subscribes to that information that comes across, it's right now it's looking for on and off. That's all it cares about. I don't care about anything else. I just care about on and off. Right. Yeah. And I'm just finishing the thought, but but in actuality it's I mean, I could send over a 10%. Okay, I'm going to send over a 10. It interprets the 10 because it's an integer value. It may say, okay, that it's a 10. It doesn't mean on and off. It can say, I'm going to change the power. I'm going to put the power at 10%.
You could send a color value.
Yeah.
If the light bulb supported different colors. You
Right.
could RGB it.
Cool.
It's endless. That's why we love.
You could do all kinds of
That's
stuff.
why we love this stuff.
This is like 40 years ago, Modbus,
Oh,
binary
Modbus.
versus ASCII, and it's reincarnated with a whole new board with software. You don't have to write the software anymore.
Great. Cool.
You could send you do it, I bet, temperatures. You got a temperature sensor somewhere. You send a temperature and have it display your temperature up there.
Okay. Yeah,
All
good.
over MQTT.
Yep.
Cool.
Too many T's, but that's all right. MQTT was one of those deals where it looks complicated, and then you do it and you go, why didn't we do this before?
A lot of that. I mean, some of the things we open up, it becomes, oh my shit, it's difficult. Then some things you open up, it's like, wow, that was easier than I thought.
A lot
It was like, that
A
was a lot
lot
easier than I
easier.
thought. So
There's three of the single board computers on a rack.
Oh, there, and there.
Yep.
Yep.
They're controlling my head.
Nice.
okay.
I had to
Anyways,
go back a year and a half to find that.
Okay.
so when I came up with the ideal, I'm sort of the kind of person I'm not sort of good on the fly, so I have to draw something out or somehow pictorialize it to make me also sort of start to get it in my brain on what I want to do. So what I actually did is just I sort of went in here and said, okay, as you can see by the picture, there's my mouse. That doesn't show very well up there. But anyway, there's candles in every window. So there's candles in every window. and those are the little bluish things. And the number sign is actually, anytime I do any type of IoT stuff, I give those individual devices an ID. Every device has to have an ID. So each candle has an ID going from 11 to 16. So, and, we have 7 of those. And then there's also one for the Christmas tree. We actually, believe it, I have 2 Christmas trees, one in the front and one in the back. So, so my wife told me I got to put them both up this year. So, okay, I just do what I'm told. And so we have this mantle that's actually in the family room. That's actually going to be the number 22, which is sort of the green one. And then there's a Christmas tree in the family room. It's going to actually get 2 Sonoffs because control and I sort of overrated it just so I don't put everything on one and sort of split the load up a little bit. Even though the Sonoffs are typically around 10 amps. So
yeah, that's a lot of lights.
Yeah, that's what I'm saying.
Especially with LED
yeah,
these days.
exactly. Yeah, it's not. Believe me, I know. But I just like, okay, I'll just in case they underrated it or something, or they overrated. It's like, okay, we can do 10 amps. Well, actually, we only do 2. So
Your neighbors walk by.
yeah, exactly. So basically, I sort of broke everything down, in this situation. And then the next step I actually did is went in and started to try to understand what I'm actually going to call this is the topics. These are how the topics are. That say the one at the top, and I can't point to it, but the one at the top is is 45. That's actually my house number. Then I say it's house, then the Sonoff, and then it's going to have either 11 to 16 ID. And the payload is going to be that on or off. It's actually going to be the payload, right? And there you go. You're doing
I'm
good.
Dana.
So I separated just like I did. So I separated into 4. So basically 4 quadrants, and there's a and I'm actually not using. I put the status in there as I was telling you guys before. That usually when I publish something, I send the status back. Yeah, right. So each one of those are going to be the status that are coming back, and I didn't use them as much as I planned to, but so anyway. So the next step is that I said, you know what? I don't want to have to turn all of these little silly things on individually. So I sort of grouped everything and saying, okay, turn on the candle, okay, turn on the living room, turn on the family room, turn on, on-offs, and then turn on, all the lights. So I can turn all the lights on, hit one button, turn all the lights on. Instead of saying, okay, so, and how that happens is this next thing here is that, so I took, my mouse came back temporarily. There it is. Okay. Slow down. There you go. Good. He's back. Okay. So this is my sort of functional description. So what I decided to do is create another, and I'll show you how it all comes together. But I used another 82. What's his name?
8266.
8266. Wow, you think I always remember that? Another 8266. And it's actually, what I did is code it inside of here and group those candles, for example, all together. So all I have to do is send one command to here to turn on or turn off the candles, to turn on and off the living room, or to say, okay, I want to just turn everything on or turn everything off. At the end of the night, and I'm gonna, I'll just hit this. It'll actually it's gonna happen automatically because I haven't talked about it yet. But there's a timer in there, but it'll turn everything off at one time instead of So I can go into so this is sort of the display part that actually is the control for all the lights. As you can see, each one of the functions maps over to here perfectly, except for this little timer, which is sort of afterthought, is saying, okay, so I can set this timer, and then again, I want it to come on a certain time of the evening, and then turn off at sometime that night. And I put this little check. By default, you bring this up, the timer actually takes on whatever time it is now. And I could have changed it, but I didn't want to go deal with it. So I just put this little check mark here and say, so this comes up. When it comes up, that's not checked. So when I check it, now it says, now I'm looking at the timer. Now I'm looking at the timer, So, and so all I gotta do is click that on and leave it alone, and it'll do its thing. So.
And you can override it, right?
Yeah. Oh, yeah. Actually, yeah, that's a good point. Yeah, I can just go up and click this, and it doesn't really. So I can at any time I can turn them on or off.
So the off time, does that have a checkbox?
No, actually, this is enabled. It basically enables
they
the time.
Come as a pair.
Yeah, and I didn't have enough real estate actually to print out somewhere so I just put the check box. I know what it means.
So when you use the word functions, is that an IoT type? So those are groupings.
Yeah, it's just it's my thing that says I'm creating functions. I'm
grouping the
sorry.
candles
Yeah.
together in that room or whatever.
Okay, I just lost it. Back.
Okay.
I can't get to that over there, can I? Yeah, there you go. Yeah. The function just says I'm just grouping all the candles into one sort of function that says, okay, click one and you can turn all the candles
So
on or off.
when you use the term payload, is that a common?
That is specifically to MQTT. It's in that. That's the
Okay.
payload. It's like I'm sending this
Payload
information.
equal message.
Right.
Well, to me, payloads like the way you had it before, status was, so it seemed to me payload synonymous with command.
No, payload, well, you can say it like that. You can say the topic is the address and the payload is what's
The
actually,
message.
it's actually what's going to that address.
Well, I know, but status is also a message coming back the other way.
Well,
and you had that
Status is
separate.
also a payload.
Oh, is it? Okay.
Yeah,
On the
yeah.
previous screen,
Yeah.
it was separated.
Right, yeah,
But
yeah.
yeah.
Yeah, you
Okay.
have, you have.
I got it,
Okay,
I got
okay,
it now.
Okay,
Thank you.
okay. So, we'll go to the next screen. Okay, so here's how this all comes together. Wow. So,
Magic.
it's good, yeah, really. So basically, I which one? Okay, Christmas light. Okay, so I pushed the button for it doesn't matter. I pushed the button for living room Christmas light. So it publishes to the broker. Then the broker so the broker's just got the message. Now this right here is actually where all those functions, where I grouped all the functions, right? So yeah,
I see what you've done.
yeah,
Okay.
so I don't have to individually control these. I grouped them all into one ESP8266. So all I do is send one command or 4 different commands now, right? You can say 8, but it's basically 4 functions, and then the payload will be on or off. So I send that to here. It subscribes to that. It reads it. Then it says, okay. Now I'm going to go in and do some magic within here to say, okay, I'm going to turn on all of the lights, or I'm going to turn off all the lights, as opposed to me having to, every time I do, I have to individually say, turn this candle on, turn this candle on, turn this candle on, turn this candle on. So I grouped it. So I used that.
You can go also using topics. You can
Yeah.
say a topic that is
I could.
everyone on.
I can, yeah, you can use a pound sign. You can use a
Well,
topic pound sign.
That's
Right.
what that. It makes sense after I saw this picture what you did, but couldn't you make one button have 4 different things, send 4 different MQTT
Oh,
things?
for sure. Yeah, I just.
So you could eliminate one of your 8266.
But see, that's the point. I actually wanted, because what I wanted to do is to make it more, I wanted to make it more where I can create a whole nother panel, for example, or I can send one command from my cell phone. Now I can send a command from my cell phone to turn all the candles on, and I don't have to do it in my cell phone and send 7 different MQTT topics. Or I can do the PAL side, of course, but I don't have to think about it. I can program it in my phone for those 3-4 functions,
Right.
and I got it. I don't think it's not syncing totally, but
It's partially there.
Right.
I'm partially buying it.
no, yeah, and I mean that's okay. I mean that's okay. It's just it was a decision I made, from
So
my,
the logic's great,
yeah.
but unless it's just the way the software libraries that you've got, the code you've already got, I'd put that logic on the broker.
Yeah, that's what I was.
Oh,
thinking.
and the broker?
No, I was
To do
thinking
the
on the
grouping
panel.
function, you could put it on the
Well,
broker.
you don't want to put it. You definitely don't want to put it on the broker.
Why
You may
not?
put it down here because
No, I want to have multiple panels. I only want one broker.
But no. Once you set one panel up, you could duplicate that for multiple panels. You make
The broker's already got all the information.
Yeah.
Well, the broker, but the broker is a sacred area, not to be screwed with from my standpoint, to be screwed with and putting all this extra code in here. It's like, because then if I have to change something, I'm gonna go screw up the broker. I don't want to ever touch the broker.
I don't think you want to mess with the broker, but you could.
I could do
you
it
could
in-
program one button to do 4 different things,
And you are absolutely 100% correct.
or 5 different things, or
You-
12 different
right.
things, and then
But-
duplicate that across multiple panels.
But see,
one topic may be a general order.
oh,
Just you send it in the on for this topic, and all the no, modules are subscribed to the general order. When see on, everyone.
Okay,
on.
but now I pick up my phone, I bring up my MQTT little app that I've downloaded, right?
And you have a button that says all on.
No,
Yeah,
I don't
but-
know. This is just a off the shelf MQTT app.
The app doesn't. The app won't let you do 4 different
Thank
things
you.
against the
Exactly, but it allows me to do one, and
Yeah.
all I got to do is candles. Boom.
I'm with
Right.
you. I'm with you on that.
Right, because it's
I've dealt with those
Yeah,
apps.
it's
that
not-
don't
You are
let
doing
you
doing
do
a
4
single
different
thing that
things.
is everyone on. It's a single
Yeah.
thing.
Yeah, it is a single thing, but what the point is that I would have to send I'd have to send 6 of those to turn all the candles on. Or I can do the pound sign. I can do the pound sign
Without writing your own app.
That's right. Without writing my own app.
I'm with you.
Right.
I just.
And that's all I'm saying is that I have a utility on here that I use for testing. That's
I'm
on my
with you.
phone.
I know exactly what you've done now.
Compatibility with third-party tools is a plus.
Yeah, and that's the thing. I can use any third party tool off of my phone, off of anybody's device. I can pick Leroy's device up and say, okay, I just got to send this in this topic and send the payload.
I know what topic I need. I know what payload.
Right, and that's the only. I mean, point well taken. I can easily move that functionality down to the panel. I mean, I can. But again, we make these decisions while we're going. It's like, it was easy for me to do on that one. Like, okay, big deal. So anyway, moving right along.
You could have also made all your Christmas trees subscribe to a whole entirely different topic.
Yeah, it's endless. It is absolutely endless.
But yeah, I'm with you. I've got it now. I know what's going on.
Okay, so here's the
I'm not going to give you a hard time about it anymore.
I love it, man. It's all good. So that's why we're here. So anyway, so these are at the end is just kind of showing you basically how. So this is the development area where I'm actually developing. This is a Raspberry Pi sitting down here, which is HDMI to this monitor here, right? So basically, I'm just gonna. I don't know which one this is gonna show. Oh, this is actually gonna show. This is actually
door lock.
Yeah. So you'll see the display. This is actually what's on my garage. So I have these little little magnet reed switches basically on, and it'll show them going on and all. Yeah, see, like and they got the red things. Oh, they're so cute.
Nice.
So anyway, that's. I think that all the last ones are just.
Huh.
Oh no.
I wonder where you got that funky display.
I know, right? I know. That was your idea. I thank you for that. And that's another one actually running over here. And this is actually, I don't know what's on there now. I've seen all kinds of stuff on it.
You took that funky idea and expanded it.
I ran with it, man. Like you say, that's why we're here, huh?
Yeah.
Okay, let's see if I can get my, I'll just touch it over here. Sure. Okay, so this one, this is, I think, I can't remember. This is actually my little test gig set up, so. And I think the only thing I wanted to show here is that, remember I was telling you I have this, these are sewn off, they come off, you buy them in China. And see that little display thing? You see the light flash?
Yeah.
That's actually my heartbeat on me in this case, because I couldn't actually I didn't want to do the second thing, so I just, every 10 seconds, I think it was, and then you can hold the button, it'll come on. So I'm just, so the manual control still works. So I can actually individually go around and turn all the candles on too, or turn them off. So okay.
You can't find the button right
Yeah, that's right. Yeah, I can't hold the camera and help find the button at the same time.
So if you query them at this point, do they know the state they were last commanded, or whether the light's on?
See, that's one of the things I skipped over and I didn't do on these, because if you remember, if I go back just for kicks, if I go back here, you'll notice that over the lights there's no red or green bar.
Okay.
So I didn't go to that point. I could have actually each individual solo actually does send a status back. So I could go and query them and see what their status is, but it's like I ain't doing all that.
It's Christmas time.
It's just I got 1 month of this and then it'll I move on. And believe me, they go Christmas lights go up the day before Thanksgiving and come down on New Year's Day. Period. My wife said, "Why do you keep up 12 days of Christmas?" I nope, they're down. I'm done. Get back to reality. That's right.
Christmas is
It's
almost
over. Okay, so so this one was basically to show. Then this one actually shows, Eric. This one actually shows how the lights are actually going to come on. Ding, 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 ding. You can't just turn them all on. You got to do something. So all the candles are
How
going
do
to.
you do the sound?
Yeah, that's right. The ding ding. So they come on and go off with this sort of actually this 5 millisecond pause.
We could go.
Exactly, and I was thinking about that. Of course, how every hour it'll come back and say. And that's the nice thing about this stuff, right? I mean, you have this idea all of a sudden. It only takes a little programming to change that whole thing.
But you gotta add the sound effects with it.
Yeah, I know. I'll put speaker outside thing.
No, it's Manchester Steamroller.
Yeah, that's right. Yeah, Manheim Steamroller, exactly.
Yeah.
Manheim Steamroller, that's right.
I'm trying to make them English, I guess. I don't know.
So there's 15 minutes left. So is that enough time there, Vicente? I am done.
No, mine is
I
fast.
like it.
Hey, thank you.
We're gonna need some more time.
Oh, you need
Mine
more
is
time
10
there?
minutes.
Oh, I'm done.
Okay.
That's it. It's a wrap.
That's a wrap.
So how long do you trust those relays to last and something like that? I mean, you don't want to turn them on and off a lot,
Right.
but
Yeah, and
they are relays.
Are they
Yeah, they are.
mechanical?
They're sealed. They were sealed. What do you call them?
Yeah.
They're like
Those.
okay. They're sealed relays. I have played with those and had those for a long time because now the old mechanical ones, the oxidation
Oh,
of
so
it.
they're triacs. They're not an actual relay.
Solid state.
No, they're actually a contact, but they're sealed. They're sealed contact.
Okay.
They're not like the old the old mechanical relays where you can see the contact. I got some like 2 years ago.